Hello students, today we start a new topic, measurement of vertical angles of chapter number 2, theodolite towers of subject surveying. So here vertical angles. So a vertical angle is an angle between the inclined line of side and a horizontal, and it may be angle of elevation or depression according to the object is above or below of the horizontal plane. So here what is line of sight? So it's a imaginary line. When the telescope is at a 0 degree and perfectly leveled and telescope is at 0 degree, so image line passing from the center of the object when to I1, so it's a horizontal line of sight, and all the above angle above the above angle from the horizontal line of sight is a positive, means all the angles are in a elevation or a upper direction, and all the angle below the line of sight, this side angle, is known as a depression or a negative angles. And here you seen a three case. Here case number 1. So here angle AOB. AOB is a summation of the angle AO, this one alpha 1, alpha and beta. So it's a angle AOB is a summation of the alpha plus beta. Now here alpha is a positive angle and beta is a negative angle. So from the positive and negative you get the exact idea about the elevation and depression side of the object. Similarly here both the point A and B, both the point above the horizontal line, clear. So both the angle we got a positive angle, and third is both the angle is in the form the negative, so both the angle below the horizontal line of sight. So it's a third cases for the vertical angles. Now second is a measurement of vertical angle. So to measure the vertical angle and object A at a station point O, so first of all set up the instrument at a station point O and level it accurately with reference to altitude bubble. So when the bubble is perfectly centered means your instrument is perfectly leveled. Now set the zero at of the vernier vertical vernier exactly to the zero to the vertical circle clamp and tangent screw. So here we already discussed about the angle, set the angle 0 degree. So when we set the angle 0 degree at a horizontal in a vertical disc, so means your theodolite is perfectly uh, uh, 0 degree, and vertically it's a horizontal, and bring the bubble tube of the altitude level in a center position by using the clip screw, and the line of sight is thus made a horizontal and vernier still 0 reading. So here when the line of sight is perfectly perfectly horizontal, so use the vernier uh, screw or a clip screw for a minor adjustment, and loose the vertical circle clamp screw and directly telescope toward the object A, or a bisect any object or a target point, and slightly using the vertical circle or a tangential screw, and then after fix the screw and read the board the vernier on a vertical scale. The means of a two vernier reading gives the value of the required angle, and change of the phase of the instrument and repeat the process. The mean of the two vernier reading gives the second value of the required angle, and the average of the two values angle thus obtained it required the value of the angle free from instrumental error. So it's a method of the vertical angle, how to measure the vertical angle. Now measurement of the vertical angle, for measuring the vertical angle between the 2 points A and B, so side A as before and take the mean of the two vernier reading and vertical circle, let it be the alpha angle. Miss average value, we got the alpha value, and similarly bisect the B point and take a two readings, and average value of the two readings we got the value is like a beta. So now some or difference of this will give the value of the vertical angle between the A and B according to the point is above or below the horizontal plane, or both the point are on a same side or horizontal plane. In a figure you already seen B and C. So see this figure. So both the angle are in a same direction or in a upper and downward direction. Here three cases are there. So all these three cases we measure the vertical angle. Now next is a deflection angle. So first deflection angle is the angle which the survey line makes which prolong of the preceding line. So here the deflection angle is designed as a right. Here are designed as a right, it's called a deflection angle, and when it is measured clockwise or toward the right side of prolongation of the preceding line. So here this line, this dotted line is a preceding line, and with respect to preceding line we measure the angle of the another line, so which is deflected. So this angle is called a deflection angle. Clear? So similarly this line Q2R line is prolonged, means in a forward direction at here, but line is turned at this direction. So here prolonging line and directed original line. So this angle is a deflection angle, and it is designed as a left L or a right L. So if line is original line is P2Q and Q2R goes to in a right direction, means deflection angle is known as a capital R. And if the angle we measure in a left side direction and the line is turned into left side direction, so it's called a deflection angle L, capital L, this one and this one. Now measurement of the deflection angle, how to measure? So these are the procedure to measure the deflection angle. So set up the instrument at a O point, set up the instrument at a Q and level it. So first of all instrument is set up at a Q point. Then after three steps are compulsory required. Here three step is that centering, leveling and focusing. So after these three steps, set the vernier A at a 0 and clamp the upper plate. So here in a when we set the instrument, set the vernier A 0 degree. So automatically in a window B we automatically set a 180 degree. Clear? Now here third point is that take the back side on a P, clamp the lower plate and bisect the P accurately by using the lower tangent screw. So here instrument is set up at a Q point, and then after bisect the P point ranging rod, and then after upper clamp is already fixed, means we set a 0 degree, and after bisecting the P point after bisecting the P point from the Q point, fix the lower screw, and your instrument is perfectly set at a P point. Clear? And here for a minor change we use the tangent screw. Now plunge the telescope. Now the line of sight along the prolongation P2Q is a dotted line, and reading on the vernier A is 0. So here telescope is now rotate, and then after prolonging line is a P2Q is a dotted line is seen at here. Then after upper clamp plate, unclamp the upper plate and turn the telescope clockwise direction, means in a right side. So bisect the R accurately using the upper tangent screw. Now here when we telescope is rotated, then after turn the telescope and bisect the R point ranging rod, and at that time lower screw is fixed and upper screw is loose, and turn the telescope in a clockwise direction. So we got the sum of the angle. So this angle is we rotate telescope in a right direction is called a R angle. So both the reading of the vernier A and B is note down, and we got the deflection angle alpha 1. Now measurement of the direct angle. So how to measure the direct angle? So direct angle are a horizontal angle measured in a clockwise direction from the previous line of the following line, next line. So here procedure is given to measure the direct angle. So here set up the instrument at a Q and level it accurately with the face left, and set the reading vernier A at a 0 degree, and fix both the plate by upper clamp screw. So here instrument is set at a Q point, then after 3 step is compulsory required: centering, leveling and focusing. And in a window A, set the reading 0 degree in a horizontal plate. Clear? Then after upper clamp is perfectly fixed, so we set the 0 degree at a Q point, and then after bisect the P point ranging rod here, and fix the lower clamp screw. Clear? Now position is that upper clamp and lower clamp both are fixed, means your instrument is fixed and no rotation is done at that time. Clear? Then after bisect the then after loose the upper clamp and rotate the telescope in a clockwise direction and bisect the R point ranging rod. Clear? So when we lose the upper clamp, so both the horizontal disc are easily rotate, and turn the telescope in a clockwise direction. When turn the telescope in a clockwise direction, angle is changed in a window A and window B in a horizontal window. Clear? So at that time we measure the sum of the angle in a window A and window B. So here this angle is a direct angle. Clear? And then after we transfer the instrument at a R point and bisect a Q point, and then after procedure is same repeated, and turn the telescope in a clockwise direction and bisect the S point. So we got this angle. Similarly transfer the instrument at a S point, and then after bisect R point, and turn the telescope in a clockwise direction and bisect the T point. So we measure the angle, this angle. And if we require inside angle, this angle, so 360 minus outer angle, so we got the inner side angle. Clear? So it's a measurement of the direct angle, and this one is a procedure. Now next is a measurement of a magnetic bearing of a line. So to find the bearing of a line AB shown in a figure, so this one is a line AB, and set up the instrument at a point, and here 3 step is compulsory required: centering, leveling and focusing. Then after set up the vernier to the 0 degree to the horizontal circle, and release the magnetic needle and loose the lower clamp. So here upper clamp is fixed when we set the 0 degree, and lower clamp is loose, and turn the telescope in a north direction point. So here in a north direction point we turn the telescope, and then after fix the lower clamp screw. Clear? Here when we fix the lower clamp screw, so our instrument is perfectly set in a north direction at a 0 degree. Clear? Then after we bisect the B point, so because AB line we measure the angle with respect to north direction. So here then after upper clamp is loose, and turn the telescope in a clockwise direction and bisect the B point, and we measure the horizontal angle in a window A. So this angle is called a magnetic bearing of a line. So why we call a magnetic bearing? Because we use the magnetic needle for getting the north direction, and we measure the angle with respect to north direction. So from the north direction we got the AB line angle. So it's called a measurement of the magnetic bearing of a line. Now next topic start is prolonging a straight line. So what is prolonging straight? Prolonging means our straight line is forward into continue direction in a same line, like A to B line prolonging to B to C, C to D, and D to up to Z. So here there are the two methods of a prolonging a line uh, of a given such as a AB. So like a foreside method, and next is a backside method. So here set up the instrument at A point and level it accurately, and three step is completely required: centering, leveling, and focusing. Then after bisect the B point correctly, and with respect to B point, C point ranging rod, move the C point ranging rod and fix the ranging rod. Movement is done in a left or right direction, and then after we fix the ranging rod at a C point. So at that time from the telescope, A point, B point, and C point is perfectly in a straight line. Clear? Now then after shift the instrument at a B point and bisect the C point, and D point ranging rod is set through side through telescope. So here from the telescope, C point and D point ranging rod is perfectly in a straight line. Then after repeat the procedure and transfer the instrument at the C point and bisect the D point and another point. Set up the instrument set up the ranging rod at a E point and fix the ranging rod. Similarly up to Z point, this procedure is repeated until at the end of the point. Now next method is a backside method. So in a backside method, as you shown in a figure, set up the instrument at a B point, and here three step is compulsory required: centering, leveling, and focusing. So take a backside on A. So from the B point bisect the A point ranging rod. Then after tight the upper and lower clamp screw and transit the telescope and establish a point C in the line beyond B. So rotate the telescope and bisect here upper and lower clamp fix. Clear? So here no horizontal rotation is done, only vertical rotation of the telescope is done. So rotate the telescope in a clockwise direction and bisect the C point. Now C point bisect. So this line is extended, and C point we find out the C dash, because phase left and phase right position some of the changes is there. So here small difference in a C and C dash point. So here in a backside method we got the C dash, D dash up to Z dash. Now shift the instrument at a C point or a C dash point and bisect the B point, and similarly line extend up to D dash point. So up to Z dash point, up to Z dash point, Same procedure is repeated, and here C dash D dash up to Z dash, these are not a straight line because due to change in a phase of the instrument or a theodolite. So here small error is getting in this method, backside method. So here standard method without any error is a foresight method. So in a foresight method, error is a minimum as compared to backside method. Now next is a double reversing method. So here when the line of sight is to be prolonged with high precision and when the instrument is in a imperfect adjustment, the process of double sighting or a double reversing is used. So suppose line AB is prolonging or extend up to Z point. So here procedure is that setup is instrument at a B point and three step is compulsory done: centering, leveling and focusing. Then after with the phase of instrument left, backside on a point, clamp both the screw upper and lower motion and transit the telescope and set the set the point C1 ahead of the line. So this C1 point, we rotate the telescope in a vertical direction and we set the C1 point. Then after loose the lower clamp and revolve the telescope in the horizontal plane, and backside is A, and A exactly by using the lower clamp is in a tangent screw. And now face the instrument at a right and transit the telescope and establish a point C2, means in a horizontal direction. Turn the telescope and we find out the point C2 in a line of the B side of C1. Now the exact point or a position of the C must be midway of the C1 and C2, means we find out the average value of both the point or a middle point and we mark the point at a C point exactly midpoint of the C1 and C2, which is the line of a true prolongation of the AB line. So AB line is extend up to BC line, and then after shift the instrument at a C point and backside is a B, and upper and lower clamp screw is a fix, and then after rotate the telescope in a vertical direction and we got the point at a D1, and then after in a horizontally we got the point at a D2, and midpoint is a D1 and D2 is a midpoint is a capital D. So this procedure is continue up to Z point and we got the we prolong or extend the line up to the end of the point. Now next topic is error in a theodolite work. So this topic we discuss in a next lecture. So here we complete or stop our lecture. Thank you.